So this is a small but a very nice question to explore in place sorting in array, and we will see what it is now. Let me zoom it a bit. So now you can pause and read the question, but I'm going to tell you the gist of it. Okay, so what it is saying is that you have they say they use the term red, white, blue, okay, colors, but actually it is not important, and that you'll see as soon as you read the couple of lines, the first 2 3 lines. Okay, so basically what we have is we have an array of 0 1 and 2s. Okay, now they are not sorted. Zeros, ones and twos are all mixed up. What we have to do is sort them. Okay, all the zeros in at first, followed by all the ones, and then followed by all the twos. Okay, so that's what our end goal is. Now this seems pretty simple, right? Because it's just sorting, nothing else. But we have got some conditions here, and that's what makes the thing a little bit interesting. And so as you can see here, the input is 202110, the output is 001122. Okay, just sort it. Okay, nothing. Now let's come here at the question. Okay, the conditions, sorry. So the conditions, first is an idea. Okay, not a requirement. The idea is quite a nice idea. Okay, we should see it. So what it says is that first we'll use a for loop to iterate through all the elements in the array, and then we will keep a count of all the zeros, all the ones and all the twos in different variables. Okay, 1 for z, z for 0, t for 2 and o for 1. Okay, so we keep a count of number of zeros, ones and twos. Now what happens, we iterate through the array once again. Okay, and this time what we do, we fill up the array with o number of zeros and z number of zeros, o number of ones and t number of twos. Okay, we just go on filling. Now the result will be, we have an array which is sorted and has the required number of zeros, ones and twos. Okay, now the problem is that this condition here says that we have to could you come up with one pass algorithm using only constant space? Okay, so this above idea, it was a two pass algorithm. Okay, we needed two for loops, first to calculate, second to modify the array. Now when we have to do this in one pass, then we might think of using a second array and putting the results in the second array as we go on counting the number of zeros, ones and twos in the first array. Now there are many possible solutions, but the condition here says only constant space. Okay, so here using only constant space. So if we have to use only constant space, then that makes things interesting, and we'll see how to do that in constant space. So let me open up the images. Okay, so now okay, so we have this array 202110. What we need is 001122. Okay, simple, without using any array, without using two for loops. Okay, or more than two. So what we do is now we have two informations with us, that is 0 has to be in the beginning, and the beginning starts with index 0. 2 has to be at the end, and the end starts at index length minus 1. Length of array minus 1 is the last index, right? That is 5 here and 0 here. So, and we do not have any index for the middle because we do not have a size of two zeros and twos, so we cannot decide where the middle begins here. Okay, so we'll leave the middle out. Now consider, if we have 0, 1 and 2's in our array, and if we sort all the zeros and all the 2's, then what is left with us? Only the ones, and they will be automatically sorted because it's mutually exclusive. They are the array has a finite size, and the array is completely filled. It has only three types of element. If we sort the first two types, the third has to be sorted by itself, because all the zeros come in the middle, all the twos come at the end. Then what's left? One. And where will it come? In the middle. So that's what we are going to do. And how to do that? In a single pass. So that's quite simple actually. So what happens, we take two variables. Okay, one is a t for 2 and a z for 0, and I think I should choose another color. I think this is much more visible. So t will be 5 because that's the index where 2 has to be placed initially, and z will be equal to 0 because that's the index where 0 has to be placed initially. Okay, now what happens, so this is 2, right, and this is 0. Okay, so we'll iterate through the array, that is using I. So I is equal to 0 initially. Okay, 0, then 1 and 2, it goes like that. So when I points at this, we check if this if the element at this index is 2 or 0. Okay, so we find that the element is 2. Now once we know that the element here is 2, what we have to do, we have to swap this element with the element that is present at position t, that is here t is equal to 5. Okay, so we need to swap this element with this element, right? And swapping is a two-way process, so obviously 0 will come here. So that's what we do. And when we do this, after we do this, we will have an array like this. Okay, the 0 will come here in the beginning, 2 comes here at the end, and I is still pointing. Wait a second, and wait another second, and I was here initially. Now what happens is that I will point at, let me change the color again, I will be here, right? I will be at 1. So now what happens, so we have what was the value of t and what was the value of z. So t was equal to 5, right? But now since we have got an element at 5, so we cannot put another 2 there. So what we do, we reduce the size. So t will now be equal to 5 minus 1, that is equal to 4. So t will now point to this position. Okay, because this is already filled. So now the last position is this position. Okay, last position of the remaining array. So t is equal to 4. Z, have we encountered any 0? Yes, we have encountered a 0, but that was not at the position I. That was this 0. This 0 was actually at this position. So we actually encountered a 2, and while swapping that 2, we swapped a 0 that was by chance. Okay, not by design. So what we do not change the 0. So unless and until our I points at a 0, we do not increment the value of z. Okay, and unless and until our t points at a 2, we do not decrement the value of t. Okay, t will decrement, that is 5, 4, 3, 2, 1 goes like that, and z will increment 0, 1, 2, 3, 4 as a number of zeros or number of 2's are added. Okay, so t is equal to 4 and z will remain 0, no change here. Now we come to the second index. Here element is 0. Now element is 0, so what we do, we swap it with the element that is present as z. Z is the index with which the swapping is to be done, not the element. Okay, so z is equal to 0, so that is we have to swap it with index 0. So this will come here, this will go here, and it will not create any change because 0 swapping with 0, it doesn't matter. Okay, so that's what it is. Now what happens, I points to this position, right, because I is moving for loop. So when we have this, we see that it is a 2, and as soon as we get a 2, what we do, we swap it with t. Okay, so t is equal to 4, so we swap it with 4. We put this 2 here and we put this 1 here because we cannot lose the information. So the only possible way of saving this one is to put it in this empty space because 2 has come here, right? Yeah, so we have to swap it. Now once we swap it, we will have we will have this one over here. And now what was our, why does the color come back? So what was our t? T was our 4. T was 4 because we swapped here, right? This position we swapped here this was the 2, here this was the 1, so we swapped these two. Now the 2 comes to this position and the 1 comes to this position, so our t now becomes 4 minus 1, that is equal to 3, because now 4 is also filled up, okay, as we see here. And our z becomes, z is equal to 1 because we had only one swapping of 0, right? When we swap this 0 with this 0, so this is the 0th index, this index was filled, okay, with a 0, so that's why we had a z plus plus, or z is equal to z plus 1, whatever you like to call it. Okay, so now that we have this, so once if you look at the array is already sorted 0 0 1 1 2 2, okay, but the for loop is going to traverse through the array at least once. We cannot stop in between because we do not have any way to know that the array is sorted. So the array will traverse and it will just keep on going until it reaches the end. Okay, so and if there were any more zeros or ones that should not be present at a position, so what it will do, it will swap the zeros or ones, zeros or twos. So if there were any 0 or 2 that was present at the wrong position, then what it will do, it will swap and put the 0 or 2 at the right position. Okay, that is 0 will be put at index z and 2 will be put at index t. Okay, very simple, no problem. Okay, but there is one problem that arises when you try to write the code, and that is some extra swapping that we do not require. That is, once this array is already sorted, if this continues further and if this finds a 2, that is it will find a 2 obviously at this index 4, right? Now if this finds if it finds a value at this index, what it will do is that it will swap this 2 to t is equal to 3, that is here, and 1 to here. Now that will be a problem. Why? Because the 1 should not be present here, 2 should be present here, right? So we have got two ways to tackle it. Okay, now first is we can check using a condition that if I is less than t, okay, because at this point when all the sorting is completed, what happens is that t will be pointing at this position, right? This is t, and z will be pointing at this position, this is z, and our I will be moving. Okay, it will be here, then it will come here. So let's assume I is here. So if we do not put a condition, what happens is that this 2 and this 1 gets swapped, but we are not going to let that happen. So what happens is that we put a condition that if I is greater than t, then we have to stop it. We do not want to swap it. Okay, no swapping should be done if I is greater than t, because I has already moved beyond the swapping region where swapping was necessary. Now what I is seeing is the sorted array and we do not need any swapping. So if I is greater than t, no swapping is to be done. Okay, now in some cases what might happen is that if the number of zeros is too large, so what would happen is that z would be present at some index, okay, like assume that z is present here, there are a lot of zeros and z is present here, and we have got all so if I is present at any index from here to here, like if I is present here at this position, so what happens is that we do not have to swap it, right, the 0, because if there is a 0 present at this position which is less than z, then obviously it does not have to be sorted. So that's why we put another condition. This condition is actually not required. This one was required, I greater than t, then do not swap, but the other condition is not so required, but yeah, you can put it, that is z is less than I is less than z. The second condition, while swapping for 0, what we need to put is I is less than z. So if I is less than z, then we are not going to do that, right? Now there is another way to do it, and so the other way to do is actually a more efficient way that makes the program more efficient, because it stops unnecessary iteration or traversal of array. As soon as the array gets sorted, if the array gets sorted, I cannot say as soon as, it might iterate for a couple of elements, I'm not sure. So this is a more efficient approach. What we do is we change the let me do this, we change the condition for the for loop. Okay, now our execution for the for loop was from here to here, right? Now what we do is we do not put the condition equal to array dot length. Okay, we do not go up to that position, array dot length. What we do is we go up to t. Why t? Because t initially was array dot length minus 1. Okay, so it will go up to t no matter what, less than equal to t. That I should add, because some cases there might be a problem if all of it is 0, I suppose. Then also it will not be a problem. Yeah, but better safe side. So it will go up to t, right? Now what happens is that t will come forward, that is t will come to, let's say, this position or this position. Then that means only one thing, and that is that the array beyond t is sorted, because it will be filled with 2's, right? In that case is the only case when the t moves forward, if the index behind t are already filled with 2. So we do not have to go through the sorted array. So let's save time, let's make our program more efficient, and let's put the condition for loop to stop at t. Okay, and this also helps the program become more efficient in another way, and that is the condition that we saw previously. We had to check at every instance that if I was less than t or I was greater than t, and checking condition makes program slow. Now this is actually making it efficient, because we have to we can remove multiple conditions, making program more efficient, and we also skip the unnecessary part of array, that is the sorted part of array, thus making the program even more efficient. Okay, so now let's see the program, and now let's first remove this, open the program. So this is the program. Actually there are some boilerplate, but that does not need to bother you. This is the actual code. Okay, so we have t is equal to nums.length minus 1, z is equal to 0, right? And I equal to 0 less than t, there it should be less. If you put I less than t, there should be no problem, but I have not tested it over a lot of examples, so I cannot say that. If you want, you can test it, but being on the safe side is always better. So I less than equal to t. Okay, that will do the job. If it is equal to 2, nums I equal to 2, then just swap it, and nums I is equal to nums t, and nums t is equal to 2. You can use 3 variables, that is a temporary variable, to swap like the traditional swapping, but that is not required, because we know that the value that has to be put there is 2. So either you can use the traditional swap if you are not comfortable with this thing here, but I don't think it is complicated. I hope you can understand this. Just put the position at t into I and 2 at t, and then t minus minus, obviously, because that position is filled with 2, so we need to move forward, right? And okay, so this is not required, that was just for debugging. And similar is the case with this line also. So now you see it is such a tiny and small code, right? And yet so efficient and innovative. So yeah, just so that's what happens with 0 to nums I equal to 0, nums I is equal to nums z, and nums z is equal to 0, z plus plus. Nothing complicated going on here, just swapping the value, put the value that was present at z in at position I, and then put 0 at position z, as simple as that. And then increment the value of z, because this position has already been filled with a 0, so we move forward. Okay, so that's about it. Now if you want to see it run, then I will have to open the terminal, and that is not a big task. And boom, why did it, so removing the this is the answer, okay, the sorted array. But I wanted to show you all the steps. Okay, now I did not save it. Okay, so now you can see all the steps here, right? How this is getting, so even after being sorted, it does run a couple of steps, right? But it is still more efficient than using the first approach of using conditions where I is less than t, because that case we would have a couple more iterations, I suppose. 1 2 3 4 5 6, maybe not, who cares, but yeah, it is obviously saving time in the condition part, so this is the better way. Yeah, so that's all for this video. I hope you liked it, and I need to close it now. For that, it's not an easy task.